Okay, so thank you. Just once again, we'll be talking about networks within Azure, covering virtual networks, subnets, network security groups, application security groups, talk about Azure Firewall, DNS, and network peer. So, like I said earlier, when you need to set up a network, the basic or probably your fundamental is your network infrastructure. And your network infrastructure is defined by within a traditional environment, starting from your switch. Your switch is the backbone of your network to which your devices are connected. Your devices have got what you call NICs, network interface cards, which are connected by means of a cable, maybe a cat cable, to the switch. And this network, as it is, would have no access to another network that you have somewhere, except you explicitly allow connectivity. So let's assume I have a local network in Abuja, and I have another local network in Lagos. There'll be no direct connectivity between this local network, except I allow it using various technologies. Now, putting that in context, few seconds, please. Apologies, I need to quickly attend to something. So, like I was saying, if you don't explicitly define the means of connectivity, then both networks are not reachable. So, putting that in context, when involves a cloud environment, the cloud itself is a network. So, which means I don't have access to, or let me put it this way, by default, if I have resources within the cloud, except I explicitly define how the resources will be accessed, I don't have access to it. Likewise, resources within the cloud network, except I also explicitly define, they don't have access to if I have any existing network, to my on-premise network. So simply put, your network within the cloud can either be hybrid or cloud only. Cloud only if you don't have any on-prem infrastructure. So which means there's no need for you to connect, because you are looking at the cloud as putting this Lagos and Abuja as an instance, Abuja being the cloud and Lagos being your on-prem. If there is no need for there to be connectivity between both, you can do a cloud-only network within any cloud platform. If there's a need, both networks are separate. And in that particular case, you have to explicitly define how you would connect both of them. So that's that. Now, bringing that back to the cloud, just like the basic of a network within an on-prem environment is a switch through which you begin to connect your devices by means of a cable and a NIC. The basic of a network within the cloud, especially within the Azure environment, is called a virtual network, VNet. It has different nomenclature with different cloud provider. Like within AWS, it is called VPC, Virtual Private Cloud. Within Azure, it is called VNet. So when you set up a virtual network in Azure, this is what you have. You have this. Network. Let's say I'll call this AZ. So I have this boundary, where within this boundary, I can have different network resources, my servers, my database applications, any other thing you could imagine that can be within a network. This is what you have. So this boundary, you can liken this boundary to the switch that you use within a physical network. Now, when you have a network like this on-prem, your network can be flat in the sense that you have just one range of IP address and connectivity is allowable across all the whole network. If you remember in the fundamental class, we talked about you having a network and you having a subnet. Subnet is breaking a very large network into smaller networks, but there's a large network. You could choose to leave the large network as open, where it is a very flat network and connectivity is possible within all. But maybe by design or private requirements, you may choose to break them down into smaller networks. The same thing applies within this environment. I can have one VNet with one large IP address scope such that all resources within my network are accessible to one another. Or I can break it down into subnets. So that's why it was important for us to understand the lesson we took where we discussed subnets and CIDR. Now, what are the things that are required to create a network within the cloud? Primarily, you need just a name and the IP address. Why the IP address? Because outside, using an on-premise environment as an instance, outside is switch, which offers physical connectivity. Your network will still not work if each resources on the network don't have unique identities, which are the IP addresses. So if my VNet is equivalent to my switch, then my IP address remains my IP address within the contents of both instances. I would have to get IP addresses that needs to be assigned to my resources. And by virtue of the standard for IP addressing, I would have to come up with a block or probably a range of IP addresses that I need to use. Either if we are going through the traditional way, either I say I have a class A block of IP address or a class B block of IP address or probably class C block of IP address. The bottom line is that I would have IP addresses that I need to work with. So for you to create a virtual network within Azure, you must have both at hand. What name do you want to call your virtual network? And what range of IP addresses are you working with within that environment? So there's also now a possibility that if you have an hybrid environment, you want to link them up. In that particular case, it means that I have an existing network. I want to go to the cloud, but I want the cloud to be an extension of my on-premise, or probably my on-premise to be an extension of the cloud, whichever I want to consider as my primary data center, because you might begin to imagine your cloud presence as a data center on its own. Then also, I need to understand how I would make both networks reachable, and also how I would define my IP addresses such that they don't overlap. Overlap means that due to the fact that this is an extension of this, if an IP address 10.0 is used here, that 10.0 should not be used here again. That is, you're avoiding overlapping. So that's the idea behind VNet. It's a boundary for your cloud presence, and it could be an extension of your on-prem data center if you are considering an hybrid environment. We talked about subnets before. So I would want to believe that that concept is still very much fresh within our memory. But what we should note, like I said earlier, is that when you have a VNet, you can choose to make it a flat network where there are no subnets, or you may choose to create subnets. And when you are creating subnets, it has to be in the CIDR notation. And when you create subnets within CIDR notation, you have to understand that a minimum of 4 IP addresses would not be usable within the range. For instance, looking at this subnet, naturally, what you should have here is, say, a 254 usable IP addresses, but Azure would have at least 4 of those IP addresses reserved, 1 for your gateway, 1 as your network ID, and 2 other reserved IP addresses. So your subnet helps you divide your network. You could use it for security purposes when you want to achieve segmentation. But we'll speak to that much later. So let's just get started and look at what we have on the portal, then we'll continue the explanation. So the assumption here, let me paint a scenario. Say maybe I have a client who says we are just getting started. We don't want to begin to go through the stress of maintaining an on-premise infrastructure. We want our infrastructure to be in the cloud. So we want you to set up what will be the network infrastructure for us in the cloud. So some of the questions I'll be asking will be, what are the possible network segmentations, the size of the network now and maybe in the near future? Is it going to grow? What are kind of services are you expecting within that particular environment? What level of security do you also desire? So I'll have those informations. So the first thing I'll do is to create a virtual network. So I'll come here to say virtual network. So here you can see it says that create a virtual network to securely connect to your Azure resources. You could also connect your Azure resources to your on-prem using an intermediary, either maybe VPN or an express route, which we'll still talk about. So I'll come here to say create my virtual network. So this is a building block for your private network in the cloud. You can connect resources like your VMs to it, or probably several other services. You could also allow them connect to the internet, and interconnectivity when you have a Sarah subnet or probably even connected to your own data center. Yeah, I would create a new resource group. Let me call this week 6. Where should I put this? West Europe. So I'll call this, let me call this, one name. Okay, call this
week 6 VNet.
You said?
I said week 6 VNet.
Okay, yeah, that makes sense. This VNet. So let's assume we have a company named week 6 and they are just starting. Okay, I'll name it week 6 VNet 01 because there might possibly be a need for us to create another one. So I'll call this week 6 VNet. I can go on to say create, where it automatically assumes a number of important information for me, like IP addressing. If I don't specify one, it automatically picks one for me. So I'll go ahead to see if I don't specify, what would it have picked for me? It would have picked this range for me. 10.0.0/16, which is a very large scope. You can see 65,536 IP addresses, which is 65,000, yeah, for a medium size organization. That is just more than enough. So I'll leave it at this. So, however, but it's not a must that I use this. You could go move down to the range of /18, but you could see. So one thing I want us to note here is that this, if we are going through the traditional approach of IP addressing, this belongs to class A, right? Isn't it?
Yes.
Yeah, this 10.10. But when you look at this subnet, this is /B, which is /16, which from the legacy traditional way, which is class B. So this is telling you that here, you don't make use of the traditional approach of subnetting. That's why it's specifically noted that use the CID annotation where boundaries are broken. That means there's no class A, there's no class B. All you are specifying is what should be your subnet max, and if you are specifying your subnet max, that decide how many IP addresses will be available for you. So if I do this /16, I could as well do here and say I want /24. Doesn't change anything. It won't flag it that this is not correct, that a class A, you know, the way we were told then that a class A IP address will always start with 192. No, it's not very much start with 192, especially when you are doing CIDR or probably VLM. So this is just saying that even when your IP address, your network block starts with det10, you are still limited to 256 IP address because that is what your /24 allows you. So I can as well go back to say I have a very, 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 very large network, and it should be a /8, and that is giving me over 16 million available IP addresses. So if I'm looking at having a very large data center within Azure, then I can use this, or probably maybe I offer services that involves the use of large volume of IP addresses so that I don't run out of IP addresses. Because over time, you begin to see some other services that takes part of this chunk of IP address for use. So within the context of this, I'll go back to /16. I'll say this is what I want. Now, just to add, if I am doing an hybrid and within my physical network, what I've used is, let's say 10.10. Let's say 1.0.0 say /16. I have to make sure I don't use this. I would have to use maybe 10.2.0.0/16. They shouldn't overlap because they are two separate networks. So that means you can't use the same IP address on two separate networks. So it's very important that when using hybrid or private setting services, you avoid IP address overlap, else there'll be conflict and there'll be issues. So coming back to our week 6 organization. So I'll put that there. You can see here it says that this guy does not have any subnets. I may choose to go ahead. If I choose to go ahead, it would automatically create a default subnet for me. And the default network would come in a block of /24. So that means it will try to help me break this down into several /24 blocks of IP addresses, where I'll have up to 251 IP addresses within that block. But I could choose to create one myself. So subnet, possible subnet. I can say within the week 6 organization, I have a subnet for my web servers. And I say it should be 10.0.0.0/24. I'll add it. This web server, this is a subnet of this. So which means it has taken about 256 chunk of IP addresses out of this total that I have here, out of this 65. I'll come back to say, okay, maybe I want the finance department to be on a different subnet. I'll say this should be 10. Let me say 10. This would start at let me say 1.0.0/say 24. Okay, it's not connected. 0, yeah. I could put start with my 1 here. This still overlaps. What's my
the third digit should be 1.
Yep, that should be the third bit. Correct. 1, 2, 3, 4. Yep. So you can see this is reserving 5 IP addresses. So I'll come here to say I want this. Let's say I want say pilot network, or let's say test network. I would go 10.0.0.2/24. Is this guy showing up again? Okay, third bit, sorry, this is the third 2. Then I'll go, well, I have enough. This is a subnet dedicated for my servers. This is a subnet dedicated for the finance department. This is a test subnet. Maybe if I run an environment where I do a lot of testing and stuff like that, I could, and I want to segment, I could do that here. Then I go next to security. We talked about Bastion hosts the last time, which is you having a dedicated virtual machine, secure dedicated virtual machine by which you can connect to Azure so that you don't publicly connect to Azure, a form of security. You could say you also want DDoS, distributed denial of service protection, which is a service offered by Microsoft. So if someone is trying to attack your network by sending too much of bogus traffic to crawl or probably to crash that network, to be protected, then naturally it is expected that you don't set up a network that you want to extend to the public, because you're either extending your network to the public or you could extend it to your private network. But a large number of times there would always be need for you to extend your network to the public. If there's no firewall there, it's not like it's not going to work. It's going to work. It's just that you might not be protected. So come back to adding firewall to our network. So I need that to go ahead. I can add tags or not. So I'll go ahead to say create this guy. Click on create. So while this is creating, like I said, it's important for you to plan your IP addressing before you get started. And also note where you'll be needing private IP addresses and public IP addresses. If there's no need for any of your services or resources to either connect to the internet or be connected to from the internet, then you don't need a public IP address. So that means this guy is an island of its own. No inbound internet traffic, no outbound internet traffic. You don't need public IP addresses. All you need are private IP addresses. But if you do need that either outbound or probably inbound connectivity to the internet, you need a public IP address. And also, you might also need to connect your network on Azure on-premise, which is a local extension of your network. That is why you have private IP address, because on your local network, what you have is private IP addresses within Azure. What you also have is private IP addresses, and you want to link them up. You could either use VPN or express routes. Although each of your terminating appliance, that means your VPN appliance on-premise and your VPN appliance on cloud, would have public IP addresses. But that public IP addresses would be for them to establish a tunnel through the internet for connectivity. But connectivity among resources themselves will be through the use of private IP addresses. That is why the IP addresses should not overlap. Any IP address I'm already using here, or range of IP address I'm already using here in Azure, I shouldn't use it on on-prem as well. So why this before? Let me check if this guy is back. Your IP addresses. Okay, so this guy is done. So if I come here to resources, yeah, I can see my address space. This is it. I could add more. This guy starts here, ends here. It gives me this amount of IP addresses. I have 3 subnets, with each of those subnets having 251 available IP addresses. We saw earlier where it has flagged that Azure would reserve 5 IP addresses. So this is the amount of IP addresses that you have available. So what does that mean? It means that I have the first part of my requirements met, my network. I already have a network in the cloud. I can now begin to have network appliances and connect them to that network. For instance, let's assume the first resource they need to use is a server. They need a server that is going to host maybe a web application. So I'll come here, put this in their resource group. I'll call this, let's say, web server 01. This guy should still remain in West Europe. I want this to be a Windows server, and 64. This is going to be slow. I'll increase this to this. Name, I'll call this week 6, and I'll give the password. Not long enough. If I don't forget. Type thinking. So I'll do this. For this virtual machine, I would go say next. I'll just go ahead, say next. I'm not interested in this. I'll reduce this to say standard. Yeah, delete when you're deleting. Yeah, this is fine. I'll go. So when I come to networking here, so you can see it has sensed that I have an existing virtual network, and it has automatically selected that and just randomly picked one subnet. So since this guy is a web server, so naturally I'm not connecting it to the finance subnet. It's a web server, so I'll put it on the web server subnet We'll come back, talk about network security groups and the rest of them like that. So I'll just take this so that then I'll go just say create. I don't have any other thing to put there. So now I now have a server on one of my subnets, which is the web subnet. So we'll come back to this guy when it's done. So now, private IP addresses are free on Azure, but public IP addresses, you are charged for them. And what are those things you can use public IP addresses for? You can connect them directly to a virtual machine's NIC is network interface card, just like the normal network interface card, or probably the Azure 45 ports that you see on a laptop or probably on a physical server. Yeah, that is the equivalent within the virtual machine. That is what you assign, because naturally in real sense also on your system, what you are assigning an IP address to is actually the interface network adapter or network interface adapter. So an IP address can be assigned to a virtual machine's NIC. You could assign it also to a load balancer, a public IP address, because your load balancer also, you could, you know, the way a load balancer works is if I have a load balancer here, if we remember when we talked about resiliency and availability, I would have several servers here, 1 server, 2 server, 3 server, 4 server, 5 server. What's the purpose of the load balancer? So that it helps me share traffic across these servers. So if I have 10,000 traffic, instead of one server taking one traffic, this load balancer receives the traffic and it shares it across this guy. So, but this load balancer presents itself as just one identity. So this is abstract. You don't see what is behind the load balancer. You don't know who is there, how many of them are there. So for your front-end configuration, you need a public IP address, which is what users would access. Back-end, from the load balancer to the servers in the pool, you would use a private IP address. So for your front-end load balancer configuration, you use the public IP address. For your VPN gateway also, remember I said when you want to extend your on-premise to your cloud, and you would have VPN gateways on both ends, even though communication between both networks will be private, but the establishment of the tunnel through which they route that traffic would be through a public IP address. So your VPN gateway will require a public IP address. Likewise, if you have a web application gateway, which is an appliance that you could use to control traffic to your web servers, in some instances, it could include the functionality of a load balancer, or maybe a combination of a load balancer on a web application firewall, a WAF. For that also, you need a public IP address for the front end. Your IP address, your public IP address can either be dynamic or it can be static. Dynamic means that once you create that public IP address, you assign it to any of these resources. Once the resources is started, a random public IP address is assigned. And once that resource is deallocated, that IP address is withdrawn. When you start that resource again, a different IP address will be assigned. It works in some cases where it doesn't really matter if your IP addresses changes. But in cases where it matters that your IP address should remain the same, you could use static IP address. So for static IP address, what you'll be paying will be more than what you'll be paying for a dynamic IP address. Then also here, you are told that a public IP address is available only in certain units, or probably the your SKUs are actually unit of pricing and availability. It's a common word, stock keeping unit. You could see it maybe in an e-commerce site or stuff like that, but it's not tied to. So you are just saying that it could be available maybe in certain region or probably in different pricing. So that is for public IP address. What about private IP addresses? You could use your private IP address also as a connectivity for your VM, where it is assigned to your NIC. you could also use it for your load balancers, front end, and even back end. But here you are seeing front end. Then you now ask, how is it possible that you use front end? It's not in all situations that either your load balancer or your web application gateway is connected to the public. You could have a service internally for which you need a load balancer. In that particular case, the front-end IP address of the load balancer need not be a public IP address because it's actually an internal service for which you need this load balancer. So your Azure automatically assigns IP address for dynamic IP addresses, or you could also be specific to say you want static IP addresses. Instances of where you want static IP addresses, especially for internal environment, are for your servers and services. For instance, I have a domain controller. The IP address of my domain controller should not be changing. I have DNS server. The IP address of my DNS server should not be changing. Maybe I have web servers also. The IP addresses of my web servers should not be changing because when I'm tying them to my load balancer or probably to my application gateway, I'm tying them using those IP addresses. So it can't be changing such that I'll now have to begin to change that configuration every now and then. So that's for IP addressing. So let's come back to portal here and look at how we create public IP addresses. So this guy is done. Our VM is up. If we come here, you can see this guy has a public IP address. It also has a private IP address, which is 10.0.0.4. It is picking that from that subnet we created earlier. If I come to this public IP address here, this public IP address is actually a resource on its own, and I can see it is dynamic. I can change it to static if I want. If I come here to say I want it change to static, it says that for me to do that, this IP address, this virtual machine will have to restart so that it reassigns that particular IP address. Now, without having the IP address automatically created for me when creating services, I could as well create the public IP address myself, even when I don't need it yet. Maybe I would later create a resource that would use it. I can come here to say create. Then here, I can come here to say I want it to be a version 4, a version 6, or a both. And you can see it can either be a standard stock keep unit or probably a basic, which means you could have a different pricing tiers. The basic would be less expensive than the standard, but for the standard, you could use it for certain services for which you can't use the basic for. For instance, if you want to use a public IP address for a load balancer, it has to be the standard tier. Then also, you do want it to be regional or global. Regional in the sense that that IP address is only available within the Azure region for which you have created it, or it is global. So which means if I make it regional, I can only use it for resources within the Azure region I've created it. Maybe a virtual machine that I've created within the Europe, the West Europe. I have a virtual machine within West Europe. I created the public IP address within West Europe, then I can use it. But if I created a public IP address that is regional in, let's say, US Central, I can't use it for a VM that I've placed within West Europe, except if that IP address is global. So I may also want to decide if this IP address, if there will be a need for me to use it across different regions, I could, what's it called? Put that here. Then also I could give my IP address a name, a DNS label. What resource group will it be? I can put it there. So let me call this WAF IP, Web Application Firewall IP. I want it to be global, which would definitely be more. This guy, I could create this or probably leave it. It's not important, but we'll still come back to talk about DNS. So I'll go ahead to say create. So that would create a public IP address for me. And when we come back, so let me refresh this, it's done. Okay, go to resource. So I have my WAF IP address here, and this is the IP address that was assigned, and it is global, it is standard. If I come back to this virtual machine here, if I come back to networking, here I can see my network interface adapter. I can see that I have my network interface adapter. I've got a public IP address assigned to it, and it also has a NIC with a private IP address assigned to it. So if I come here, IP configurations, here I can see for the private IP address, it belongs to this subnet, so it automatically picks an IP address there. For the public IP address, although it's automatically assigned, but I can come here to say add. Let me call this test 01. I want a static IP address. If I can specify the IP address, let's say 10.0.0.5. If I want a public IP address, I can add. You can see I have one that I've created here. Of this stuff is not structured. You can see my WAF IP address that I've created here. I can assign it if I want this guy to have 2 public IP addresses. So I can assign this. If you remember, so this guy says the public IP address SKU must be the same for all configurations in the network. So what does that mean? If I come to my public IP address, we'll come back to this. If I come to the public IP address here, I think this guy is basic. This guy is basic. Let me come back to IP addresses. I guess someone has mic on. So you can see this guy is basic. This dynamic IP address that was automatically assigned to my web server is basic, although I could upgrade it. So what that error was saying is that if on a server, I already had a public IP address that is basic assigned to it, if I want to assign another one, that's basic. If I have it assigned as standard, if I want to assign another one, then it has to be standard. Well, I was about asking a question. Now, under what situation would you have more than one? Well, for a private IP address, you could think of, but a public IP address, under what situation would you think that it would be necessary for you to have more than one public IP address? Any idea? We discussed one in one of our classes there. Hello?
Probably for load balancing your server. I think you should have different ones, like one server, one service, but cutting across multiple.
Yes, for load. Yeah, that's actually correct. So if you have a load balancer that you can use for more than one service, yes, each of them would always have a different IP address tied to them. So the load balancer will be using them as a virtual IP address. Although those IP addresses will not be directly connected to the load balancer. But in a situation where you'd have to directly connect to it, just like we are doing here, where I would have to assign another network interface adapter, or maybe assign another IP address to network interface adapter. A very similar situation would be where I have one web server and I need to host several applications on them using the same port number. If we remember, where I have a web server that I need to be accessed through port 80. You know, when setting up your IS, you have to map an IP address to the port. So if port 80 is currently being used, I can't host another application that would use the same port 80. It's either I change the IP address or I change the port number. So if I want to be able to use the same port 80 for another application, then I have to assign another IP address to that particular server. That's a very good instance of where you can do that. 10.0.0.0.5. Then okay, I can associate this, so I'll just leave it as a static private IP address. So this is going to add another IP address to this particular machine, but this time around just a static private IP address. So that's basically about IP addressing and networks. So you can see this is static, 10.0.0.5 is static, 10.0.0.4 is dynamic, and I have one public IP address there. Now, you've completed the next part of the requirements that says you have a network, you have IP addresses, maybe subnet, you're able to use that public IP address or probably static IP address. You also have access to public IP addresses as required. But now, if I have my server hop here now, and it has a public IP address assigned to it, I can access this server publicly. If this is not meant to be a server that needs to be accessed publicly, then I know I don't need this public IP address. I could just go ahead and take off that public IP address. And when you look at this interface, okay, starting from bringing up this particular server and the fact that it has a public IP address, what it means that anybody from anywhere can access this server. Either access it directly, connect to it, maybe through RDP, or access any of the resources or private services it is offering. If it is a web server, an FTP server, a DNS server, it's just going to be accessible. In most cases, that would not be the requirement. A server would be very specific with what services it will be offering, and access should only be limited to those services. So which means you have to put a layer of security to say, allow this, do not allow this. And how do you do that? One of the ways you do that within the Azure environment is creating what we refer to as network security groups, which is a layer of access control on your network or the NIC of your VMs or appliances, as the case may be. So I want to be able to say directly to my server, allow this, do not allow this. Or on the network, allow this, do not allow this. Knowing fully well that my VM is going to be connected to the network. So I can either decide to define my security rules at the level of the VM's network adapter, or I define it at the level of the network itself that it is connected to. So what do you use network security groups for? You could use to limit traffic to a resource in a virtual network, and you do that by creating rules, allow and deny rules. And you can associate those rules to a subnet or a network interface. You can associate to a subnet or a network interface, and there can be different or probably multiple rules associated to the same network or network interface. Then it will now use a logic to decide which of the rules to apply. By default, when you create a virtual machine, even when you don't specify a network security group, due to the fact that you may have specified during the creation of that virtual machine that you need access. For instance, when creating the web server, if you come back here, sometimes you may not observe it, but let me initiate the creation of another web server. Come up, and I would use that to place this on a different subnet. So this guy still be with 6. I'll call this web server 02, still web 0, still the same thing here. I'll call this week 6 again. I'll call this So you can see at this point, it is saying inbound port rules. Select which virtual machine network ports will be accessible from the public internet. So indirectly, it is telling you, asking you that, do you want to make this virtual machine accessible on the internet? If the answer is yes, then it wants you to be specific. We can't just make, now, by default, a network service, not a virtual machine, a network appliance has over 65,000 possible ports. Some of those ports are categorized into ephemeral ports and standard ports, where a standard port is a port that is known for a particular service, where ephemeral ports are ports that are not tied to any specific service, and majority of time they are used as destination ports, while the standard ports, sorry, they are used as source port, while the standard ports are mostly used as destination ports. Example of a standard port is this 389, which you know is for RDP. When you are connecting to RDP, if RDP is your destination, so it uses 3389. If your destination is HTTP, which is the web service, you're using port 8005 port 443. So, but for your source port, it's not specific. It can be random. So they are randomly selected. You could have maybe 57,000 something, some of those large number ports. So that's the idea. So, but now, you can't leave the whole port accessible, the whole over 65,000 port accessible on your server. That is not what's it called, a good security decision. So that is why this is there by default to say at the point where you are creating this, tell us, do you want to allow specific ports? If yes, check them here. I want to allow SSH, but now they are limited to this. Why are they limited to this? Because by default, this will be the most common use or probably initial form of connectivity when you set up your network device or probably appliance. Then you can begin to do the configuration for others much later. So they have retained, and all these are standard 80.443.22, 389. So I can say I want RDP. If I say none, then I have challenges connecting to this virtual machine, especially from the public, except if I have defined a bastion host. So here I would say I want RDP. So due to the fact that I've specified this, the means by which it would achieve this is to create a network security group. So this would automatically create a network security group for me. But for the purpose of this, because I had created one that has a network security group and a port allowed, I would create this without any. Then we'll see how we can assign it manually ourselves. So here, I'll change this to this. For my networking, I would put this is the first one was in the web servers. I'll put this in test. I'll put it in test. Network security group, I'll say I don't want any. All ports on this virtual machine may be exposed to the internet. This is the security risks. Okay. This would not block. Although I said I don't want any ports open, but I'll still leave this. I'll leave this way so that I would use this to manually assign. I'll check this. Then I don't think I want anything else. So I'll say create. So while that is being created, I would come here. Okay, oh, still a mistake. I'll have to recreate this again. I didn't click on the last create button. Okay, administrative server. 02. Yeah. Week 6. Said no. Said next. Reduce this guy next. So this guy should be in test. This guy should be known. This guy. Then create. Then create. Okay. So while that is creating, I'll come to say, okay, I need certain rules to control connectivity to my network and possibly to my virtual machines. So I'll come to say I want network security groups. This was the default one that was created for us when we created the first web server. But now I want to create another one. I'll go ahead to say create. I'll put this still in my network security group. I'll call this NGS 002, still in West Europe. I'll go ahead to say create. Then I'll say create. So why these guys? Okay, it's done. So let's just go to it straight. So this is my network security group. And what do you have in network security groups? You have rules. And your rules can be inbound or outbound. Inbound means the rule controls connectivity into your network or into your virtual machines. Outbound means the rules controls traffic out of your network or out of your virtual machines. Now, when you create a network security group, there are rules that are created by default. You have 3 inbound default rules and you have 3 outbound default rules. And what are those rules? These are the rules you have here. The first one is allow VNet inbound, which allows connectivity within the virtual network. So it is saying if any traffic is come from the virtual network and it is also destined for the virtual network, allow. So which means connectivity within itself is allowed. And that also applies for outbound rules. If anybody within is sending traffic out to anybody within, allow it. Then the second rule, if there's a load balancer and the traffic is coming from the load balancer and going anywhere, this any means anywhere. And since this is an inbound rule, it means coming from a load balancer into any resource within my network, allow it. Then you have the default deny, which is deny all inbound. This deny is saying if there's any traffic coming from anywhere we mean maybe within the network or outside of the network, and to within the network or outside of the network, it will deny. For some of us who may be familiar with maybe access control list within network appliances, like maybe a Cisco router, or probably we've had opportunity to work with firewalls before, would understand how these rules are being treated. The rules are being treated by virtue of their IDs, where the one with the smallest IDs will be treated first, and it flows down. So it is from top to bottom. So it means that it will check this rule. If it matches, it applies this rule. If this does not match, it checks the second one. If this does not match, it takes the last one. So this deny, in a large number of cases where it defines, it is always called an explicit deny rule, where you are still providing a denial rule for any rule that you have not specified. So that means it's just saying, if I have not allowed you, then indirectly I'm denying you. So which means if there's no rule above that has allowed you, by default you are denied. That's what that means. And that deny is that if you are from anywhere going to anywhere, you'll be denied. And the same thing also applies for the outbound rules. If it is from virtual network to the virtual network, allow. So you can see this outbound here. If it is from anywhere and it is going to the internet, so this would allow that network or virtual machine to be able to connect to the internet. If it is going to the internet, allow, else deny. Those are the default rules that are specified within a network security group. So you would now, and a large number of time, it doesn't apply for your use cases. By default, yeah, connectivity within the virtual machines will be allowed. If I have a load balancer, it will be allowed. If I want to connect to the internet, it will be allowed. But if I have a VM here, and I need to connect to the VM by RDP, none of this rule applies to it. Because if it is RDP, what that means is, where is my slide? If I have the VM here, and I have a network security group here, network security group. This is the internet. This is going to be an inbound rule, RDP 338 Z8 now 86. I guess it's 8 now. So I'm saying coming from the internet and going to the VM through port 3389, none of this rule, okay, except for this one. In this snapshot, one has been created, but from the default rule, none of them applies, because it means that from anywhere, either to anywhere or maybe to the virtual network through port 889 is not allowed. That will fall under the deny. For me to now allow it, I have to create an explicit rule that has a priority that will be higher than this or any other one. If I create this rule and give it a priority of say 66,000, the rule will be there, but access to RDP will still be denied, because the deny rule will be processed before my rule. And once there's a match, it stops processing the other rules. So that's the idea. So you have security rules that you can't delete, but you can add rules with higher priority. And it processes the rule from top to bottom, which means rules with the lowest priority take precedence over the rule with the highest priority. So let's go and create a rule there in our network security group. So what I can do here is, let's say I have my web server, the second web server I created. I want to enable RDP on it, and I want it to allow connectivity from the internet to port 80, because I'm going to make it a web server. So I'll come here to create inbound rule. I'll come here, I'll say add rule. I could say from anywhere, which is anywhere. It could be from the internet, where the source port, I'm less concerned about the source port. I'm only concerned about the destination. I can say anywhere, I can say IP address, I can say service tag, I can say application security. Now, if I'm only allowing connectivity to a specific, let's say a specific VM on the network, and I know the IP address of the VM on the network, I can put it here. Or you have what you refer to as service tags. Service tags are high layer for certain services, such that you don't need to remember what is the IP address or the port that service is using. Once you select it, it automatically takes one. So for instance, internet, virtual network, maybe you have okay, let's run through this. Virtual network, action groups, you have app services within Azure that you have created and stuff like that. So they are all called service tags. I can specify any of these service tags. Maybe I have a Azure Databricks, a Cosmos DB, or probably a Vault that I've created. Any of these. So they are predefined identified services that you don't need to know the IP address. They've been categorized, and you just need to select them. Then it automatically uses whatever what do you call it? Whatever IP address or probably port number that it comes with. For instance, the internet. Within the internet group, I have all these services that I can connect to from the internet. So since I've selected that service tag, I don't need to remember what will be the port number of any of these. I could just say SSH. Then it picks up the IP port number for me. For instance, let me say progress. I can't remember what port number progress SQL is using. But if I select it, it's there for me. Likewise, let's say my SQL, I don't know. Okay, but it's the 306. So, but here, what I want is RDP. Then I'll go and say the action is allow. I'll say add. Then I'll come again to say I want from anywhere to internet. Okay, let me say no, let me use this the other way around now, because so here I would say from the internet is actually the source. Since this is an inbound route, is actually meant to be from the internet destination to maybe anywhere, or maybe to RDP. And I want to say the priority. I didn't specify the priority for the first one here, but I'll give it a priority of 5. I could give it a name. I'll change this to RDP connection.
You need to change the priority number.
It needs to start with let me change it from 100. Yeah, so I'll give this. The first guy I created, where is it? Okay. Yeah, what's wrong with this first guy I created? There's something wrong with it. If you compare both of them, what's wrong with it? Which would work and which would not work? Any idea? If we look at these two rules, both of them involve the same port, the same service, but one is wrong. I mean, one is the correct one, while the other one is wrong.
Personally, I think it's the destination rule of the first one. The
Yeah,
destination.
exactly. The destination rule. Okay, the first one, you mean 100 or 101?
100.
100. It's actually yeah, it's both the source and the destination. And okay, let me put it, could be more of the destination, because any could be any as it is. So from here, I'm saying that from anywhere I'm going to the internet, but no, it's the reverse the case. I'm coming from the internet to anywhere port 338. So this is actually the correct one that would work, because what I want to do is inbound connection to my VM through port 338 now, and I'm coming from the internet. The connection will come from the internet, and it is going inbound here anywhere within, and through port 338. So I'll just go ahead and delete this guy. So you could also do the same thing for outbound. Create rules for outbound to say just think of anything where you need an outbound rule. Primarily, the internet is one that just comes to mind. Except, so there are situations where you need a pair of rules, in the sense that how do I do this? Where you have, we know the way the TCP/IP connectivity works, where if you have a traffic coming from the source and it goes to destination, a connectivity is established, and for that destination to respond to the source, it also needs to go through a TCP/IP connectivity that involves a source IP address and destination IP address. If that response connectivity is blocked, then there will be an issue. So which means you have to create a corresponding outbound rules to allow both inbound and outbound connection in that situation. So in that case, you may need to create both rules. So I'll come back to my VM here, the second VM. Okay, if I first, before I go back to second VM, if I come back to network security groups, if I come to this one here, and I come to network interfaces, I can see which resource is currently using this role. Presently, the web server is using this role. Do I have any subnet using this role? No, I don't have any subnet using this role, but I can still assign this subnet to a specific role if I have to a specific subnet if I have. So first, I now have some subnets within this network, and how many subnets do I have? I have 3 of them. I can say apply this rule to this subnet. So I'll leave this here, or instead come here to say, for this one presently is not currently in use either by any network interface adapter or any subnet. I can come here to say associate this rule to a subnet, and I'll select subnet test. I'll say okay. So once I do this, this rule now controls connectivity to the subnet. Now, but we said that your rule can be used for both subnet and network interface. What about the situation? Let me come back here. Let me come back here and do one assignment before we come and talk about this. So I guess I created one other virtual machine. So I'll come here, that second virtual machine I created. Where do I have it? Was it created at all? Few seconds. Virtual machine. Did that guy fail? It's not here. My second web server is not here. It's not here. Okay. Okay, no problem. I'll just use this. So let me come here and come back to this guy, network security group. My network security group, this guy, I'll come here and say my subnet. I'll assign this. This guy is currently assigned to subnet test, while I'll associate it with subnet web server as well. Subnet web servers. So I'll say okay. So this guy is associated with both subnet test and subnet web server. So let's understand this. I have a web server using this network adapter. Sorry, this. I have a web server that uses this network adapter, web server 6.4. And that network adapter has a security rule, network security group assigned to it, named this. And this web server is on a network. And that network has this network security group assigned to it, this subnet. So which means I have 2 network security group impacting that web server alone. So how does it translate or undo those multiple rules, especially when they are impacting different resources for that particular web server? That's why you have the effective rules. Number 1, network security groups are evaluated independently. So that means the first network security group would not be evaluated with reference to the second one. They will undo traffic independently. But an allow rule must exist at both levels for traffic to be allowed. So that means if this is the network security group attached to the network adapter, while this is the network security group attached to the subnet. If there is no allow rule here, this one will fail. If there's no allow rule here, also traffic will not get to the web server. So both of them must have an allow rule. And for incoming traffic, the first rule that is evaluated is the one at the subnet layer. So what the group uses to evaluate effective rule is the direction of traffic flow. If the traffic is an inbound traffic, that traffic will hit the subnet first before it hits the virtual machine. So which means the network security group assigned to the subnet is evaluated first before the one assigned to the virtual machine. If it is an outbound rule, that means from the virtual machine outside, the network security group assigned to the virtual machine is evaluated first before that of the subnet. So which means whichever of the traffic, whichever of the network security group that denies the traffic first, once that traffic is denied, it doesn't even get to the second security group. That is why an allow must exist at both levels. Then another way you could evaluate that is using what you refer to as the effective security rule link. So on each resources, you have an effective security rules where it helps you evaluate what will be the effective rule that will apply so that you get to know. So if I come back here, and I come back to that web server, virtual machines, and I come to networking. So you can say I have effective security rules. And if you see here, it is showing that for my inbound rules, I have two rules. Oh, it's telling me that you have two rules. Oh. You have one rule that is defined under the NGS 002, and that one is attached to the subnet. And you have another one here that is attached to the interface. Okay, what will now be the cumulative effect? You come here to say effective rules. And this will do the evaluation for you. So here it says that I should select an interface below to say the effective rule. The interface I have is here. Associated rules, I have these two rules. Here I have this guy. This would apply. And here I have this guy. This would apply. So if I look at this, at this level, which is directly attached to the subnet, RDP will be allowed. Connectivity within the network will be allowed. If there's a load balancer, it will be allowed. For outbound rule, connectivity within will be allowed. And what is this next one here? From here, outbound to the internet would also be allowed. This is from any source to outbound. That will be allowed. What about under this rule? What will be the effective impact? TCP, RDP, inbound will be allowed. This would also be allowed. This will be allowed. And okay, this would be denied. This would be allowed. And this would also be allowed. And this gives me an idea of what would be the impact. So at the network level, what I want primarily as defined is TCP connectivity.
Sorry, sir.
Yeah.
Sorry, sir. I just want to ask a
ahead.
question. I'm looking at the RDP connection and the priority given in place. And also there is a deny all that you put there. Deny all inbound. Looking at the source.
Yeah.
And destination rather.
Yeah.
So the destination, they both have the same destination. Hope that won't affect that particular RDP rule. Because I know in Cisco, sir.
Yeah, go ahead.
You know, I know in Cisco, I know that this is more like any IP address kind of settings.
That's
But
correct.
the source is what I'm not just, the source for the RDP is what I'm not just certain of, because that looks like you putting in the same statement. And if the destination port is more like same thing, because it's 0265535. I want started from 3389 to 3389. I don't know if you can just explain that.
Okay. So I said that there are two. Seconds. Let me bring this my whiteboard up. Okay. Clear this. You know, I said there are two categories of ports.
Yes, sir.
You have the ephemeral ports and you have the standard ports.
Yes.
So and the total number of ports that are available on any network appliance is from 0 to 65,000 plus, which is what you saw in that rule.
Yes, sir.
So the rule says that source is this, destination is 3389, isn't it?
Yes, sir.
Now, when a network request originates from a computer system, the port number that is the source port number is, number one, irrelevant.
Okay.
Number two, it is dynamic and it is ephemeral. Ephemeral meaning that it is not part of the standard port. Why is it that way? Because at a given instance, currently on my system, let me show you something. Where is my shell? Okay. So if I do, let's start. Yeah, okay. So if you see from here, okay, this makes sense. This part, this last three traffic here, or four traffic. This shows that my computer system is currently connecting to a destination, a foreign resource. I don't know, except I would, number one, since these are HTTPS, so it means that it is connecting to a particular web application or probably a web destination.
Yes, sir. Yes, sir.
Which I can figure out if I try to resolve these names. And it is doing that through port. Yeah, exactly. It is doing that through port 443. But this is the source port number. These are different destinations. And this is the source port number that my own, because you can't connect if there is no source and destination ports. But because I could generate over 1 million traffic at a time, what the system does is randomly pick any source port number from the ephemeral category. That's why this is 50,000, 166, this one is 49,000. But the destination would always be standard because you must know where you are going to. Even if you don't know where you are coming from, you must know where you are going to. Now, what that rule is saying now is that you may not know where you are coming from, which is your source. You might be on the local network, which is this. We may not know where you are coming from, or probably what number port number you are using to connect. But you are coming from the internet using any port number. But what we are particular about is where you are going to. You want to connect to port 3389, then we'll allow you. It's just like you calling, you want to call a particular number, a phone number, but you're in Nigeria. It doesn't matter what phone number you are using, because you could be using your own personal mobile number. You may be calling from a pay telephone, pay-as-you-go telephone service or stuff like that. But what is more important is what number are you calling, which is the destination you are going to. So we are saying that if you are calling from the internet, irrespective of the port number you are using, but you are going to RDP, would allow you. And a large number of time, you can see that for a large number of source ports, it is not important, so you don't specify it, except if you are blocking a particular service that you know would always use a particular port number. Let's take, for instance, you can see my browser, right?
Yes.
If I say port number for common DDoS zombies. Come here. Now, you have certain, maybe by virtue of malware analysis that has been done for certain types of malware or zombies, that when they are created and you check the process, maybe you spin them up on your system and you check the process, just like I checked this here, they will always use a particular port number. That means the developer had created that part. You know what a zombie is? Just to give context, sometimes you could have malware in your system where that malware spins up a process and tries to connect to a command and control center, where the command and control center will be like a server being controlled by the attacker. Then the attacker now recruits your system as a zombie and now begins to use your system to either initiate a denial of service attack against some infrastructure, or even for crypto mining. They could be using the excess resources on your system to mine crypto. You wouldn't know. Now, if I had known, maybe in the news, I've known it that, oh, they said a particular malware application, let's, for instance, for the sake of this conversation, let's call it, let's say, Zombie A. Zombie A would always spin up a process and use a source port number of 519 to connect to the command and control center. If I know and I have that information, I can use it in two ways. Number one, I can create a rule that would block the destination if I know the IP address of the destination. Because I can't go to create a rule and block HTTPS. You know the reason why? Any idea?
Come again, sir.
I said I can create a rule if I know the source port address of the malware and I know the destination port or IP address of the malware. I can create a rule to block the destination IP address, but I cannot create a rule to block the destination port, especially when it is HTTPS. And I asked, do you know why I can't just go ahead and block HTTPS?
Because if you block HTTPS, bearing in mind that it's not just that particular maybe destination that is using HTTPS as a protocol.
Thank you. Exactly correct. If I go and block HTTPS, it means that every other legit service that uses HTTPS will be blocked. But if I know the IP address specifically, I can block the IP address. But if I don't know the IP address, and I know the source port, which is an ephemeral port, random number, I can block it as well. There will be no issue because for a legit service, it would not be using a fixed port number. It will randomly choose. So which means if this port 5195 is not available, it will use another one, and I don't have a problem with it. But I only have a problem with that malware. It will always use this port 5159. And one way I can block it is to say if there's any traffic coming from source port number 5159, then block it. Then in that instance, I can change this to 5159 because I know specifically to say this malware, this is the port number it will be using. But for a legit traffic,
you don't know what port number it will use because it randomly generates it. So you would always use this option. I hope that's clear.
Yes, sir.
But for the destination is to a specific service. I want to isolate that service, then use here. Unlike here, where you don't want to isolate that service. From here, I'm saying from anywhere within my local network to anywhere within my local network, allow. So here, for both source and destination, I'm not concerned about the port. The same thing with the internet. From anywhere within my local system to anywhere on the internet, I'm not concerned about the port. Wherever you like, you may be connecting to, as long as it is outbound, then I don't have an issue. So that's the idea behind that.
Please, I have a question.
Yeah,
The
go ahead.
load balancer.
The load
Is it-
balancer.
Yes, is it a specific instance to you, or it's just referring to Azure's load balancer itself?
So in this case, this is a service tag, and it is referring to Azure load balancer itself. You can create a load balancer if you have a institution that requires that you use one. So if I create a load balancer here, and I've used that service tag here, so it is referring to any instance of Azure load balancer. You can also be very specific if you are not referring to all the instances you have within your environment. You just want one specific instance. Then you can probably use the IP address of that instance in your rule when creating your rule. I hope that's clear.
Yes, thank you very much.
Yeah. So that's the way network security group works. And if you come back here, just to still give context to the last question you asked, this is a inbound rule. So if I say I want anything inbound, then I may not care about the source, but I care about the destination. So if I know the IP address, for instance, if I don't want to use a service tag, where the service tag I will say all load balancer. This will refer to all load balancers. Then here I can say I know the IP address of the load balancer, then I put it here. So any traffic coming from the internet or probably anywhere to my load balancer with this IP address and trying to connect to, say, maybe this service, then allow or deny. That's the way that works. So now in addition to network security group, you could have application security group. So let's look at it this way. If I have, say, okay, let's assume I have just one subnet. Yeah, okay, let's say maybe two subnets. Let me use instances. I have two subnets. Because I've implemented network segmentation, one subnet will be for my web servers, and one will be for my, say, databases. But within these web servers, I have two groups. I have internal web servers and I have external web servers. So internal web servers will mean maybe it's hosting web applications that can only be accessible internally. It is used within the corporate network. You can't access it from the internet. Why we have external facing websites, because we need them to be accessible by the public. Let's say maybe our corporate website. So within the same subnet, but I have two groups of web servers, internal, external. Then let's say maybe I have databases as well. My databases are going to be, let's say, internal only, because I don't want them accessible externally. Now, if within this internal web server, servers, I have, let's say, 5 of them, and within external, let's say I have 10 of them. Within this guy, let's say I have 7 of them. What it means is that when I create a network security group, I would have to assign it to 2 subnets, one subnet 2, depending on the rule. Then maybe I would have to assign it to, this is 50 15 plus 7, that is about 21 or probably 22. I have to assign it to 22 network interface adapters, NICs. And each time I create a new server, I have to come and do the assignment. I have to associate that network security group with the web server. That is not really much of a work as such. But however, as you begin to grow and scale, and you want to be able to manage or probably make changes to your security group once, and it applies to a range of services at the same time, then you may want to begin to look at the idea of using application security groups. And what are application security groups? They are just set of applications that host similar, or set of servers that host similar applications and should have similar security groups. So what you have now, network security rules. And what you have now done is to create a group for them, put them together, all the servers in that group, and create an application security group such that it is easy for you to assign a network security group to the application security group. And when you apply it to the application security group, it automatically applies to all the servers in that group. I hope that's clear. I'll create a group, put all my servers in that group. Instead of assigning network security rules to individual servers, instead I'll assign it to the group. And once I assign it to the group, all the servers in the group takes that rule. That is what that means.
Application security group cut across subnets. So like if I have a web server across 3 different subnets, can I pick each of the application servers, group them as an ASG?
That's if you have all the applications in different subnets.
Yes.
Yeah, even when you have the applications in different subnets, you could actually pick them up. So if they're in different subnets, no, you can't group them up together, especially when your target is to target the NICs of each of those particular servers. Because mind you, your network security group can actually be assigned to either a subnet or probably NICs. So you want to place them within the same subnet, all the application, all the servers that are within the same subnet, so that the rules that you apply either applies to the subnet altogether, which is one subnet, or they apply to the NICs of the servers altogether. So that's, so coming here, yeah, to see how this works. If I come here to say web application security group, we are done. Okay. If I come to application security group, so you can use application security group to configure network security as an extension to your application structure by grouping your VMs and defining network security policies based on those groups. And you can reuse the security policies without manually maintaining IP addresses and the likes. So I'll come here to say our group, create a group. I'll put that group here. I'll put this guy, let's say, web servers. Call that web servers. Then I'll say create. So in a few seconds, this guy would come up. Yep. So I'll go to resource. So presently, this is my group. So the way this works is if I come to servers here, where is my web server? Okay, virtual machine, web server. And I come to networking. Here you can see I have application security group. I can say this guy belongs to this application security group, web servers.
and I'll say save. Then, so this guy already belongs to this. Then I would have to come to my network security group. Come to network security group. Let's say this guy. Okay, let me do that from let me create a new one. Network security group. Okay. Put this guy here and NGS3. Say create. Yeah. So if I come here to create, let's say, a rule, and I'll come here. So here, if you see, I have the option of specifying an application security group. So for that web server, let's say IS. So, and this is an inbound rule, okay, for every traffic coming from the internet, going to specifically port, okay, source port, I don't care. Okay, specifically going to this guy, application security group. Here, I have web servers. So, and this guy is going to port, say HTTPS. Yep. Then priority, I'll go and say add. So the reason why I didn't create this on the existing network security group I had, that I most likely already have rules assigned to one other subnet or probably or the other. So I'll just create this afresh. So now this is saying that if you have any traffic coming from the internet that is destined for these web servers, then it should allow. And what do you have in these web servers? I have I have just one server presently, but it could be a group of servers, maybe 3, 4, for instance. Maybe I have web servers that are meant to form part of a pool, and they are going to be behind my load balancers. So instead of defining that for them individually, then I'll just do this to the network security group, and I'll assign each of those web servers to the network security group, sorry, application security group rather, and that works. So yes, someone is saying application security groups seems to follow the MVC framework. Well, naturally, MVC framework is an application development methodology that helps you separate your separate layer of abstract layers of your application, your model, your view, your control, and stuff like that. Yeah, if it is in the way that it operates, possibly, but there is naturally no direct correlation between the application security groups and your network security group, as the case may be. They are tailored towards different use cases and application. Then load balancing, expatiate more on load balancing. A load balancer is just like the name implies.
an appliance that balances load. And I guess I've given instances. I'll list all of this. So if I have one server, let me start with, if I have one server, maybe this is Jumia. They just started, and maybe they started with customers, and within every day they are generating, let's say, maybe 2,000 traffic. 2,000 traffic. At 2,000 traffic, say maybe this server is eating say 60% CPU utilization, say 60% bandwidth usage, that's data traffic, and it's fine. Their progression is that maybe in the next 2 weeks it's going to increase to say 3,000. If they increase to 3,000, this will begin to eat, let's say, maybe 80%, and this guy begins to slow, becomes very slow and drag. So naturally, a site that will respond in, let's say, 5 seconds, you now take say 2 or 3 minutes to respond, and even in some cases it throw an error to say resource not available. That's because it's being choked up with so many requests. What can they do? We talked about scale up or scale down, or probably you scale horizontal, or probably scale vertical. In this particular case, we'll be scaling horizontally. That means they'll go and get another server. Let me put that here. They'll get another server with the same Amazon Jumia website on it, maybe the same spec. So that means you either connect to this or you connect to this. But users do not know that you have 2 servers, and your URL is still the same thing, www.jumia.com. So what would help the user route their traffic? They will introduce a load balancer. So users' traffic would eat the load balancer. Then the load balancer will use some metrics to decide which of the servers to respond to that request. You have a lot of metric, hashing, maybe queue, and stuff like that. It will come and say, okay, now you are currently attending to 10 requests. Oh, you are idle. Oh yeah, you take the request. That is what the load balancer does. So it shares or probably manages the load across several, and Jumia can continue to scale by adding more servers behind the load balancers. The more server you have, the more the load balancer shares the load. So that means each of the servers will begin to do less work and will be very responsive. That is what a load balancer does. I hope that answers your question. Let's talk about Azure Firewall and Storage Swift. I would call it a day. Now, network security group applies to either your NIC or your subnets. And use it to control inbound and outbound traffic. And you make use of some parameters, ports and IP addresses, or maybe services, or maybe service tags. But even though behind your service and service tags, you still have IP addresses. That is what your network security group does for you, your NIC or your subnet. But you know that on a network, before you even hit the subnet or the NIC, you hit the network itself. I hope you understand. In terms of hierarchy or direction of flow, your traffic hits your network before it gets to your subnet, before it gets to your devices. In this case, maybe your server, the NIC and your server. So I have offered one level of traffic control at the level of my NIC, at the level of my subnet. But what about my network? Which is what's it called? The direct extension. My network is what gives me the direct extension to the internet. So you want to be able to also control traffic and also offer some kind of security controls. And that's why it is called a firewall. A wall built with fire, which means before you get inside the box, you have to battle with the fire. So the Azure firewall is a stateful firewall service. Your firewall can either be stateful or stateless. A stateless firewall is a firewall that controls traffic based on parameters within layer 3 alone. And what do you have within layer 3? IP address and port number only. That is what it uses to control traffic. But a large number of times, you have security breaches that can circumvent controls that are implemented at layer 3 alone. And layer 3 is at your network layer where you have your routing protocol and stuff like that. But now you want to go beyond that. Let's take, for instance, let's put it in context. Olaiton, are you there? Hello?
I'm here, sir.
Okay. On a Cisco, let's say Cisco router.
Yes, sir.
If I say, okay, when federal government said they blocked Twitter.
Yes, sir.
Anybody who has an idea of how that could have been implemented by the service providers, that a large number of us can't access Twitter?
Yes, sir.
Any idea?
So, from my own layman, okay, sorry. Say that again.
When we're told, when there was a ban on Twitter,
yes, sir.
You know, a large number of us can't access, even a large number of us. Everybody in Nigeria couldn't access Twitter now.
Yes, sir.
So how did you think the service providers did it? Such that even if you are using MTN network, you can't. You are using Spectranet, you can't. You are using Globalcom, you can't.
Okay, so from my own perspective, I think the way it's being implemented is that, for you to route on the internet, you have been seeing like a number, which is the public IP. So for a particular region, that particular IP, public IP, or from let's say Nigeria as a nation, they restrict all IP coming from Nigeria as a nation so that you won't be able to access the Google or, the Twitter platform. But for ISP related, let's say IPNS or main1, what they need to just do is that all the public IP that have been given out to their, to their client, they just restrict Twitter or maybe, Twitter or any of these social media. They just put a block to it. No outbound or outgoing traffic from that particular end. And let me now bring it down to my own workplace. Before then or now, we've already blocked all those social media, even now that they've lifted the ban. So what we did was on our own router, we just go to the outgoing traffic. Then we just put in the, Twitter or Google or Facebook. We just put it there, then put a limit to it. But I now, for maybe somebody that uses VPN, VPN by default, we just route you to another country or change your primary IP to something else. That is how I was able to access it then, even when there was a blockage on it. I think that was what was done at that point.
Yeah, that's correct. So naturally, what the service providers would do is to get the IP address of Twitter and just block it. So naturally, since you are routing your own traffic through their network outbound, what they'll be saying is that any source IP address with a destination port of Twitter will be the internet 443, and destination IP address of Twitter's IP address block. They need to drop that traffic, so it won't go through. But
I want to ask a question regarding the same thing. Let's say when that ban was implemented, I noticed that for some service provider, even after they block it for some phones, it takes a while. Maybe it was cache we were using then. I just wanted to speak a bit into that. It takes a while before it actually was fully implemented on other people. Even when it was lifted, it takes like 2
before the people could access it.
days before I could even use it with my MTN.
Yeah.
Yes.
Truly, it could be catching the speed of propagation of their rules across their network, because for them, they would have a large number of network appliances that does this routing and traffic control. The time it takes for that to propagate is a factor. So, but apart from that, I don't know, maybe a number of us would notice that even while that ban is on some network or some devices, you still get Twitter notifications, but you can't access it.
Yes. I was getting
Twitter notifications. That is because primarily Twitter runs a microservice architecture where each of those services are isolated on their own, and a large number of times they use different IP addresses with different APIs. So the actual Twitter portal may have been blocked. But if a service provider does not go ahead to identify other APIs and microservices used by Twitter and identify the IP addresses and block them, those ones would still work. That's why you get your notification, but you can't access the content because the actual portal has been blocked. But that is by the way. Now, if a rule is created based on just IP address and port number, just like the case of Twitter in this case, it is very possible for an attacker to circumvent that particular rule and introduce some kind of stealth attack behaviors on the network and still circumvent that. For instance, if you are blocking Twitter because we know Twitter uses port 443, and you block IP address of Twitter port 443, all Twitter needs to do is to add an additional port number through which you can reach them. There may be a port, one kind of port address that is not known, say port 772. Then how will users reach them through 772? www.twitter.com/772. That will go through, because on the firewall, what was blocked is just IP address and maybe the port number 443. It could also be in any other form. But the bottom line is that for any firewall rule that is created using layer 3 parameters alone, then there could be a lot of ways by which an attacker could circumvent that. Another instance would be where for instance, in case of VPN, although let's not even, because VPN is even more secured, but without even using VPN, let's assume it's on a local network. Take, for instance, on your own local network in your office, where you are using IP address restriction. You want certain devices with certain IP addresses to be able to access certain services, but some users with certain IP addresses should not be able to access certain services. All I need to do is to go and get a static IP address from the allowed range and give it to my device. Then I circumvent your firewall restriction or control. Those are some of the challenges with using basic firewalls that operate at layer 3. More advanced, and they are called stateless firewall. Stateless firewall because they only look at the point at which you are initiating that connection. Anything after the connection is not checked. What type of data are you transferring? What type of other parameters that goes through your packets? Because when you look at the OSI model, if I bring that up here, OSI model, let me see, okay. For some of us that may be familiar with the OSI model, you can see at layer 3, that's where you have your network layer, where you decide the path for data to take. But beyond that, you have your transport layer. where you do your TCP, UDP connection. You have the session layer, you have the presentation layer, you have the application layer. Now, what a stateful firewall would do is to offer level of protection using parameters between layer 3 and layer 7. So, for instance, let's say someone is tunneling HTTP traffic through an FTP connection. FTP would naturally be port 21. HTTP would naturally be port 440. But you blocked port 80 for HTTP traffic, but you allow port 21. An attacker could tunnel HTTP requests through port 21. You wouldn't know that is going on, and they are still able to access resources that you don't want them to access. But due to the fact that any firewall that operates at this 7 layer is able to inspect the content of the packet as regard to each of these individual layers, it knows at either maybe the session layer or even the application layer that, wow, at the network layer, the packet says is for 440 for port 21. But here, what I'm seeing here are HTTP parameters, then it still blocks it. That makes it more intelligent than just a layer 3 firewall. So it's a stateful service that operates at layer 3 to layer 7, offers configuration for layer 3 to layer 7, and it is highly available. It is intelligent. It comes with an IDPS, that's intrusion detection and prevention system as well, such that if you create rules, if it detects any misbehavior, it can block it automatically. That's what the Azure firewall rule is. More like just any other advanced firewall that you have around, maybe a checkpoint, a Fortinet, or probably a Cisco ASA firewall. When implementing Azure firewall, it is always advised that you use the hub and spoke methodology. That means especially when you have several virtual networks. Now, I have several virtual networks, maybe 6 or 7, and I have just one firewall I want to pay for. You can spin up a firewall for each of those virtual networks, but if you still want to use one Azure firewall for each of those virtual networks, then you use this architecture. This is just a recommended architecture to say, put your firewall as a central location and route the traffic for every other subnet through that firewall. A very good instance of that is where you have different office locations. Say you have Lagos, you have Abuja, you have Port Harcourt, you have London, you have Dubai. Lagos is your headquarters, and that is where you have your internet traffic from your service provider. Then you have a firewall here. Each of these individual locations can have their own direct internet connectivity with the service provider, and you have a firewall there. It's possible. But if you want to centrally manage their traffic and use the same appliance, what you would do is to route internet traffic from Abuja through Lagos, that of Port Harcourt through Lagos, that of London through Lagos, that of Dubai through Lagos. So in Lagos, you are able to see what are those traffic or probably network transactions that goes across each of these locations, and you're able to apply rules as required. So that's what this architecture is talking about. And on your firewall, as a firewall, you can create 3 types of rules. NAT rules, network address translation. You can remember I told us to go and check up what you have NAT and PAT. Now, NATing can be used in 2 separate scenarios. Number 1, I have now, number 1, what we need to understand is that any transaction connectivity within the internet cannot be done with private IP addresses. It has to be a public IP address. So which means if I'm connecting to the internet from my office now, even though a public internet is not assigned to my device, I'm still using a public IP. but it's just that at the router or network layer, some kind of nothing is being done. My private IP address is being translated to a public IP address that is now used on the internet. In the reverse also, if I have a web server that is hosting a website on my local network, and I don't want to expose that web server directly to the internet, what I will also use is NAT. That means on my firewall, I would assign a destination, I would configure a destination NAT rule that when you connect to my public IP address through a particular port number, I know which server you want to access and I route that traffic to that server. So Azure Firewall allows you to do destination NATing. You could create normal network rules at layer 3, maybe specify destination IP address, destination port. You could also create application rules that has to do with standard application services like FTP, HCP, SMTP, and stuff like that. Those are the rules. And just like your network security group, there's a processing order for Azure Firewall rules. The first set of rules that are created, that are processed, are network rules. After it is now processed application rules. The reason being that within the ASI model, network-related transactions are treated first because it is possible that you even block an intrusion at the network layer even before it gets the application layer. So if a traffic has been blocked at the network layer, then there's no point treating it at the application layer. So that is why it is processed in this particular order. Network rules are processed before application rules. And once a rule matches, it doesn't check other rules again, just like your network security group. Now let's see how this works within Azure. So first, if I come back to my virtual networks. So this VNet 6, I assume, is my primary virtual network on which I have all my resources. I have connected devices. I have 2 web servers connected. I have several address spaces and the likes. Now, I want to protect, even though I have network security groups at the level of my subnet and at the level of my servers NIC, I want to be able to protect the network on its own. Then what I can do is you can see here, it says protect your firewall with a stateful layer 2 to layer 7 firewall. I don't have it here. So I can come here to say configure. I either do that from here or I search for Azure Firewall from here and go ahead and create one. So I'll add a new firewall. Now, if we come back to this architecture, where is it? Let me clear this. You would note that by default, either from this architecture or for those of us that must have seen a firewall, probably worked with a firewall before, your firewall would always come with more than one interface. You'd always have a port connecting to the local, because it's an intermediary appliance. You'd always have a port connecting to LAN, and you'd also have a port connecting to WAN. That means one connecting to the internet and one connecting to your local network. Then you have your firewall. So this is your firewall here. You are blocking anything coming from here. So it would have to connect to 2 networks at the same time. Because of this purpose or this reason, Azure Firewall would always require that you create a separate subnet for it within your network. It will require that you create a separate subnet for it within your network. And that doesn't apply to Azure Firewall alone. It applies to several other network appliances, even if you are using a firewall that is not from Azure, because maybe after this, we'll look at the Azure market and see what other types of firewalls you can use if you are not using the Azure Firewall. So I'll call this firewall 01. Now, my subnet my network, my virtual network rather, if I come to my virtual network, which region is my virtual network? West Europe. I can't go and create a firewall in US Central to say I want to use it on a network that I created in West Europe. So you have to be mindful of that. So your firewall has to be in the same region that you have your network. So if I come to West Europe here, West Europe, for availability purposes, we've talked about this. For availability purposes, you want to use availability zones. That is, deploy more than one firewall in different zones so that if one goes down, the other one is still available. But for now, I don't need it. Your firewall can either be standard or premium. The major difference between the standard and premium are advanced intelligence that your premium offers you, like threat intelligence based filtering and IDS and IPS. Those are some of those stuff that the premium one offers you. So going back to the portal. So here I'll still go for premium. So I'll see some of those features that this guy has got. Then, so mind you, I said that you'd have to create a subnet. And that subnet must be named this. It is a requirement. You know, if I come here, this is my VNet. If I come to subnet, these are the subnets I have here. I can't use any of these for my firewall. And I can't even create another one and just name it firewall. The requirement for Azure Firewall is that within the network where you would use it, you have to create a subnet, and the name of the subnet must be this. So I'll copy this and I'll put here. Now, here comes the question of, oh, what should be the subnet range? Due to the fact that this is a network appliance, naturally, you don't need more than two IP addresses within the Azure Firewall. So if I give it a /24, it's an overkill. I can give it, let's say, maybe a /28, which gives me 11 IP address. Although it's still too much, I can give it a 29. That gives me 3 IP address. But instead of 3, although naturally gives me 8, but Azure will take 5. I can leave it here, or maybe I go back to 28. So you can see how we're able to use a smaller set of IP addresses by just playing around with the subnet marks. So I'll go ahead to name this guy Azure Firewall subnet, and I'll click on add. Once that is added, I'll come here and refresh this to start this again so that it would pick that Azure Firewall subnet.
A question.
Yeah, go ahead.
There is create a subnet and a gateway subnet.
There's what?
What's on the page where you created a subnet?
A subnet.
Now.
Yeah.
Then
so now a gateway subnet, yeah, just a gateway subnet is also one of okay, let me come back to this architecture. If I come back here. Okay. This is a hub network. A hub network most times is a subnet that is central to several other subnets. That's why it is called hub. So which means other subnets can connect to it. Now, these are separate networks. They are different from subnets. I hope we get it. This is a network. These are networks and not subnets. Within these networks, you can now have subnets. Now, in connecting this subnet, this network to this network, when you want to connect two networks together, naturally, you need maybe a router or a network appliance like, let's say, firewall. You could use a firewall to connect two networks together. Now, within Azure, you have several options. You can do what you call to VNet peering, or you can use a gateway appliance. When you are using a gateway appliance, part of the requirement for the gateway appliance is that it must be on a gateway subnet. When that subnet also naturally would not need more than, let's say, between 3 to say maybe 5 IP addresses. Just like it is a requirement for the Azure Firewall to be on a subnet named Azure Firewall subnet. That is exactly where you use a subnet, what's it called? A gateway subnet, where you create a gateway subnet. When you need to connect two networks together using a gateway appliance, either an Azure gateway appliance or probably third-party gateway appliance, for instance, your firewall can still serve as a gateway appliance. If I want to connect to improve security, I want to connect this hub network with this spoke network, but through a firewall. But the fact that it is an Azure firewall, which already has its own requirements, I'll create a firewall subnet for it. But if I'm using a third party or probably other appliance, I'll create a gateway subnet. I hope that's clear.
Yes, thank you very much. Then I wanted to ask for like regular, not non-cloud architectures, you have things that they call DM. So for if you are trying to replicate something on the cloud, where would your DMZ be?
Very good question. In this architecture, this is going to be my DMZ. Let me clear all this. In this architecture, this is my DMZ. And what is a DMZ? It is that subnet or probably a part of your network that offers connectivity to the internet, behind which every other network are restricted. So it is the boundary between your secured network and the unsecured network. So naturally, what would you have on a DMZ? You could have your security appliances, or you have shared appliances. Shared appliances or shared services are services that need to be accessed by the secure local network and the unsecured public network. For instance, maybe a web server that is publishing a publicly available web service, maybe a DNS server, because I want to be able to resolve names locally and also publicly. I hope that's clear.
Thank you very much.
Okay, please, I have a quick question. Referencing the example you gave about the Twitter ban.
Yeah.
Is it that there is no security measure that can be put in place regarding using VPN to access the Twitter, because they couldn't stop us from using Twitter using VPN? Is it that there was there's no security measure in place for that?
Yeah, that's also a very good question. When it comes to number one, putting in the context of Nigeria, we are not that sophisticated to do that. That's number one. Number two, even where we are that sophisticated to do it, it is difficult, it is challenging. Why? Number one, it means that you have to restrict the availability of publicly available VPN service. Or number two, individuals can set up VPN services on their own. What do they need? Since this is a regional restriction, what do they need? They just need an IP address that is assigned to a different country. For instance, let's assume that the government was able to say, okay, all public VPN services, because number one, they can't ask them not to do business. They are publicly available. But maybe they paid them or whatever, you were just able to reach an agreement to them to say, oh, Namecheap VPN, Just give me random names of some of these VPN services. They reached out to them to say, please, we want this to work. Don't accept clients from Nigeria. Yeah, that may be possible, even though it's going to be difficult. Then what can people do? I personally can come to Azure here, set up an appliance. It could be a firewall appliance. It could even be as small as a Windows server. Install routing and remote access services on it. Get a public IP address from a US region. Then I set up my VPN. I connect to that particular server to gain access to Twitter. They can't ask Microsoft not to offer services. Then moreover, Microsoft does not know what I'm doing with my server within their network. So it is difficult. So even in countries like let's say China, in countries like China, it's difficult, even though there is a ban on them across, even for most VPN services, there's a ban, but people still get their way around it. And why is it possible for China to go to that particular extent? Because the government of China itself has got control over the cyber infrastructure of the whole country in its entirety. IP address range, maybe standard regulations against providers and stuff like that. They have all those things in place. They have policies in place. That's why it's easy for them to say, we don't want a particular, unlike which, well, the government only tried when it took on Twitter. They only tried. Naturally, if they're to be in China, there could be several other means by which you could achieve that. But we on this part of the world, we are not that sophisticated. We don't have those infrastructure, maybe policy or probably regulations in place. It's going to be difficult for the government to do it on their own because these are services that are publicly available. We don't have any infrastructure that does censorship of internet access or private connectivity. For instance, in China, there are certain things you can't access. Even when you're on social media, there are certain content you can't post in there. They are being censored. And this is always being done by the government and sometimes in partnership with some of the service providers. But here, they can't, as at then, or maybe tomorrow, as at then, they couldn't do jack.
Yeah, I understand. So they probably, it might need to have been done like over time, not just within a short period.
Exactly. Some of us will remember that at some point in time, there were speculations that they want to introduce cyber censorship, and they were actually working with some was a company in Israel. That was during Jonathan's time or thereabouts, and they needed to give the contract to them and stuff like that. If they want to do that, they can do it. All they just need to do is to, number one, be in total control of the IP address space of Nigeria. All IP addresses being registered within Nigeria, be in control of it, and begin to have infrastructures in place that controls traffic that is routed into the Nigeria cyberspace. And how would they do that? They will do that in partnership with the backbone infrastructure providers, a main one, because these are the people who brought internet into the country. They control the channels by which they, for instance, the main one Galaxy backbone. You have that also. There's also a backbone connectivity being offered by maybe a rack center and stuff like that. These are means through which traffics are routed out of Nigeria. And it is at those points that they can begin to block or probably control us to a large extent. But I don't think it exists as of then. So coming back to this, I'll come here and just do this. I'll give this guy Firewall 01. This guy said it's going to be in West Europe. Oh, West Europe. Then here, I'm not concerned about availability now. Firewall policy. I'll come back to this. We'll have to create a policy. So a policy is more or less like a container for all our firewall rules. So I'll give this guy. So here, it's saying, do I have an existing virtual network? I'll say yes. And this is my virtual network. Then my public IP address, I would create a new one. Okay, so yeah, I made this guy is saying the prefix for my subnet should be smaller than 26. So if I come here, it should be smaller. What I used here was 28. So I'll come back here. So smaller than 26 would be 25. Okay. So I'll leave this way. One 23. That's still a lot, but I'll refresh this. With 6, Firewall 01, West Europe is here. Premium file policy will come back to you. My virtual network is this guy. So no error. Then new IP address. Okay, we created one IP address there. That's this guy. Okay, so we didn't use it, so I can use it now. I'll get the firewall to use this IP address. Yeah, what subnet region? Okay, I guess the region was West Europe, so that's, it won't be an issue. So here, I'll come here to say I don't have an existing firewall policy, but I'll create a new one. My firewall policy can either be standard or private premium. I'll store this guy in West Europe. I'll call this policy 01. So the policy is more or less just like a container for your rules. So I'll go ahead to say okay. I'll come here to say create. Now say create. So although we have two more topics to cover here, DNS and VNet peering, but it's already 12:40. Once we are done with this firewall setup, we'll take questions if there are any, then we'll continue from there next class. Why this is creating, if there are questions, can take them now.
Hi, Raj, please, I have a question.
Yeah.
The premium and the standard firewall, what are the major differences?
Primarily advanced features like IDPS. Your premium would include threat intelligence and intrusion detection and prevention system. While your basic would not include that.
But generally, all Azure firewalls, both standard and premium, are stateful.
Yeah, sure. They're all stateful. What's this guy saying? one error. What's the error here? That's the issue. If this guy does not come with details. Okay, conflict. What's the conflict here? It's a status field. Or is the IP address being used somewhere? I'm not sure I used that IP address. Let me check. That's the only thing I could think of. Oh, I did. Did I? Let's see. IP address. I didn't use it. I didn't. And it's even saying it's associated to web firewall 1 now. But web firewall 1 failed. Okay. So how come it failed? But it appears that it was successful. This is web firewall 1, but here it still said failed. Okay, provisioning state. It didn't. Yeah, exactly. It didn't. It didn't complete the deployment, but an instance was created. You could still work with this instance. So here, I can see this is what the firewall looks like. You said? I didn't get that. Oh, I can't hear you. If you're asking a question, I can't hear you. Maybe you could type it. The sound is a little bit poor. So you can see these are some of the things the advanced feature offers you. TLS inspection. What is this TLS inspection? You use TLS to encrypt packets. If you use the premium and it's turned on, what that means is that even when the packet is encrypted, what the firewall does is try to decrypt the packet to check the content of the packet if it's malicious or not before routing it to the destination. Then you also have IDS and IPS. That's intrusion detection and prevention system. So I guess because this guy didn't deploy successfully, this guy in the off state. But our primary concern here is when we look at our firewall rules. You can see presently we don't have any firewall rules. If I come to policy, it is within my policy that I create my rules. I could have destination NAT rules, which are rules that I can use to offer internet service for my web-facing application. So let's assume someone had created a web server, and on that web server, they had installed an application on it. That web server is on my local network. And the person has come to me saying, please, I want people to be able to access this, my web server, which is on a local network with a private IP address. I want them to be able to access it publicly. Sometimes you hear the word of, please publish this application for me. That means make it accessible on the internet. What the firewall administrator or whoever is responsible for managing this firewall needs to do is come and create a destination NAT rule. You give the NAT rule a name. I'll call this maybe web server. I'll give it a name. I'll give it a priority, let's say priority 100. Then I'll specify what my rule will be. Sorry, I didn't do that. Come back to, I'll specify what my rule will be. That's your destination NAT. Then your network rule is just like your normal network rule of maybe source to, so you can see from here, I can specify a source IP address. I can put that here, a protocol, I can put that here. For instance, sometimes when you ping certain public IP address, you don't get responses. It's not as if maybe the service is not up. It just means that they've blocked. So I can say from anywhere to ICMP, and destination port would also be anything. Is someone talking? Destination IP address, I'll specify that here. Maybe if you ping my web server, which is on 10.0.0.4, I don't want it to respond. Then I'll call this web server ping. Then I'll create this rule, give it a name, web server network 100, and connection here is deny, and call this guy default network role. So I'll say add. So what this would do, you can see this is just a basic network. This guy is still failing, updating previous state. This is just a basic network rule saying that I want to control inbound and outbound network traffic using network rules. For DNAT, it is when I need to publish a service using NAT. For application rules, naturally, if I come here, I'm going deep down into, say, maybe a layer 7, where I have to specify specifically, maybe this one is for SQL service. I want you to begin to probe the content of every SQL traffic that comes through my network, 001. Depending on what my rule would look like, I can either allow or deny. For instance, source from anywhere going to HTTPS. So you can see here I have HTTPS, I have MSQL. Then here, this is the TLS inspection. So if I say 443 here, HTTPS. Yeah, HTTPS here, because TLS inspection is disabled from that firewall creation itself. But if TLS inspection is enabled, if I check this, what this will do is that for any traffic that matches this rule, maybe the traffic is going to Microsoft.com or probably anywhere, even when the traffic is encrypted, the firewall will decrypt the traffic, check the content, be sure it is not malicious, then re-encrypt it before it sends it to the destination. Because one of those ways by which attackers bypass firewall rules and restrictions is also by encryption. Reason being that any traffic that is encrypted has to be decrypted before you can analyze the content. And that is also the reason why, speaking to what we were discussing earlier, in some countries, you can't use encryption. Cryptography by individuals or private individuals is not allowed. Only the government can use cryptography when it comes to maybe encryption, decryption, and stuff like that. So that is those are the categories of your firewall rule. And other things, like we said, IPS, TLS encryption. Then here you have a SNAT, where you have a source. Now you have SNAT and you have DNAT. Although I'd asked us to check what is the difference between both of them before, but just to give us context, if I have on my local network, this is my local network, I have 200 users with their computer system. They need to access the internet. On the internet, this is my internet. I need public IP addresses. You can only communicate on the internet using public IP. Then you get your firewall here. You create a SNAT. You assign a public IP address to the firewall. Let's say a 151 IP address. You create a SNAT rule. What this is saying is that if anybody is coming here that needs to go to Facebook, the computer system will come with its own IP address and tell the firewall to say, I want to access Facebook. The firewall will take that traffic, encapsulate it, and assign it its own public IP address, and it will go. The internet now assumes that, oh, this guy is using a public IP address to connect, which is the way internet service naturally works. If you check on your local system now, what you have is a private IP address assigned to you by your whatever it is. Maybe if you are using hotspot, assigned to you by NTN, or if you are using SpectraNet, assigned to you by your service provider. But if you come here to say, do something like this, this is my public IP. And this is the IP address offered me by the firewall of my service provider using SNAT, Source Network Address Translation. So which means for every traffic I generate out of this system, it goes to their network, they pick up the packet, they encapsulate it using the IP address of their firewall, and they send it out. On the internet, this is the IP address that is seen. They can't see my private IP address. That is SNAT. Then we saw DNAT, which is the opposite in the reverse direction. For DNAT, I have here, still on my local network, I have a web server that I am hosting. I don't want to give this web server a public internet. I don't want to place it on my DMZ. I want it to be on my local network, and it is using an IP address of 192. It is hosting a web application using port 80. What I'll now do on my firewall, this is the internet. I'll create a DNAT rule. The DNAT rule will say map 192.80 if the public IP address of this firewall is 151 to 151 port 80. It will have a translation table. So what that means is that what people on the internet who needs to access this web server needs to do is they need to connect to 151 port 80. When they connect to 151 port 80, the traffic goes to the firewall. The firewall checks its table to say, oh, who did I map 151 port 80 to? Oh, I mapped it to this web server, which is at 192.80. Then it routes the traffic to 192.80. This is DNAT. But both of them are doing address translation, public to private. I hope that's clear.
Yes.
So those are the rules. So you can do your SNAT rule. You can create that here. You can create your DNAT rule. You can create that here. So would call it a day here. Probably next class would pick it up again here from Firewall and recreate this firewall, because this guy is currently at a failed state, and a number of these stuffs are not working. So we'll pick it up from here, and next class we'll talk about Azure DNS. We'll talk about network peering, that is connecting two different VNets together without using a gateway appliance. Any question? So if there are no questions, activity for this week would be less tax 5, 6, and 7. So I'll send to us tax 1 to 4, which covers what we have discussed so far. If you have any other question, you can send through the chat in the Discord channel. Then also a number of other additional read-up tasks I would also share with us, just to increase our scope of understanding regarding what has been discussed. So enjoy the rest of the week.
All right, thank you.
Thank you very much.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, Mr. Lekon.